We've graphed absolute value equations. We've graphed two variable inequalities. Now we're going to put those together and graph absolute value inequalities. So we're going to graph y is less than or equal to 3 times the absolute value of x minus 1 minus 2. Remember, when you're graphing two variable inequalities, the first step would be to graph the boundary line. Well, this is going to be a V-shaped graph, so I'm not really going to call it a line, but we are going to graph the boundary. The equation y equals 3 times the absolute value of x minus 1 minus 2. That's an absolute value equation. The shape of it will be a V-shaped graph. And remember, you can see the vertex. This is in general form, so you can see the vertex is located at 1, negative 2, because in general form or standard form, the x-coordinate of the vertex is h, the y-coordinate of the vertex is k. So the vertex is going to be located at 1, negative 2. Now, if you were thinking that's the x-coordinate of the vertex is negative 1, that's if it would be x plus 1 inside the absolute value sign. Because to stay in general form or standard form, it'd have to be x minus a negative 1 to get an x plus 1 inside that. So the x-coordinate of the vertex is 1. The y-coordinate of the vertex is negative 2. Now the 3, that number out in front of the absolute value, that's the slope of the right branch. So the slope of the right branch is 3. The vertex is 1, negative 2. That's all you need to graph the boundary. So put a point at 1, negative 2, that is the vertex, and then the slope of the right branch is 3. From that point, go up 3 into the right 1. And since it is symmetrical, the slope of the left branch would be negative 3. So back to that vertex, go up 3 into the left 1. So that is the boundary, and that's solid because you have the less than or equal to sign. If it was just less than or just greater than, that would be a dashed boundary. Now, as far as the shading goes, do you have to do a test point? No. If that's a less than or equal to sign, we're just shading below that graph, that boundary. If you aren't sure, you could still use a test point. Remember, 0, 0 is the easiest test point to work with. So if 0, 0 works, you're going to shade the side that 0, 0 is on, or everything below that boundary. If 0, 0 makes a false statement, you shade everything above. But I can tell you right now, everything below that boundary will be shaded. So 0, 0 will work here. If I put 0 in for x and 0 in for y, end up with 0 is less than or equal to 3 minus 2, because 3 times the absolute value of negative 1, that's going to be 3. 0 is less than or equal to 1. That is a true statement. As I told you before, this less than or equal to sign are going to shade everything below the line. And you can see right there, 0, 0 is a true statement. So you're shading the side that 0, 0 is on, or everything below that boundary. So this shaded region, all of those points, and remember, this goes to infinity and beyond. All of those points in that shaded region are solutions to that inequality. So not just 0, 0, we're talking negative 4, negative 5, talking over here 6, 3, 6, negative 8. All of those points in that shaded region are solutions to that inequality. There are an infinite number of solutions, but all of those points are solutions. What is the graph of y minus 4 is greater than 2 times the absolute value of x minus 1? Well, to graph this, first thing you need to do is get this in general or standard form. To do that, add 4 to both sides. In other words, solve this inequality for y. If y is greater than 2 times the absolute value of x minus 1 plus 4. So we're going to graph the boundary, which is y equals 2 times the absolute value of x minus 1 plus 4. That's going to be a V-shaped graph. It's going to have a vertex of 1, 4, and the slope of the right branch is 2. That's all you need to know to graph that, is to pick out the vertex and the slope of the right branch. So the vertex, again, is at 1, 4. The slope of the right branch is 2. Now, if you thought the x-coordinate of the vertex should be negative 1, again, for the x-coordinate of the vertex to be negative 1, it'd have to be x minus a negative 1, which would be x plus 1. So if that was showing up as x plus 1, that's when the x-coordinate of the vertex would be negative 1. But the vertex is at 1, 4. The slope of the right branch is 2. So to graph this, start at the vertex, put a point at 1, 4. And then from there, go up 2 into the right 1. Now we're putting a dashed line down because we just have the greater than sign up here. So if it's just greater than or just less than, we're going to put a dashed boundary line. Those points on that dashed boundary line are not solutions to the inequality. So put a dashed boundary line. Again, the vertex at 1, 4, go up 2 into the right 1. That's the slope of the right branch, and it's symmetrical, so the slope of the left branch would be -2. You'd go up 2 into the left 1. So that's the V-shaped boundary line. Now, which side do you shade on? Because it is an inequality, you're going to shade on one side or the other. That shading indicates the solution set to this inequality. When it's in general form or standard form, where this is solved for y, where y is on the left, everything else is on the right, that's the sign you look at to determine the shading. Because that sign may change. Because if you were to divide, in the process of getting it in general or standard form, if you were to divide by a negative number, that inequality sign would change. In this case, it didn't. So we're going to graph out of general form, still in inequality form, but general form or standard form. That greater than sign indicates we're going to shade everything above that boundary. If you're confused or weren't sure, you could still use a test point. It just takes time. 0, 0 is the easiest point to work with. If 0, 0 is not on that boundary line, go ahead and use that. So if you put 0 in for x and 0 in for y, see if this makes a true or false statement. I can tell you right now we're shading above that line. 0, 0 is not going to be part of the shaded region. So when I put 0 in for x and 0 in for y, this is going to make a false statement. You have -4 is greater than 2 times the absolute value of -1. Absolute value of -1 is 1. So -4 is greater than 2 times 1. -4 is greater than 2. That is a false statement. -4 is not greater than 2. 0, 0 is not a solution. That means you shade the side that 0, 0 is not on, or shade everything above that boundary. So shading everything above that boundary, this is the graph. All of those points in that shaded region, this goes on forever. All of those points are solutions to that inequality. Going to graph this absolute value inequality. Y is greater than or equal to the absolute value of 2x minus 1. Remember, we have to get this in general or standard form. The absolute value of x minus h. Well, we have a little problem here. We have a 2 in front. So what we're going to do in front of the x. So what we're going to do is factor a 2 out. We're going to factor 2 out of that expression inside the absolute value sign. It's going to be 2 times x minus 1/2. So we're dividing 2x by 2. That's x. And dividing -1 by 2, that's -1/2. Now we're going to move that 2 out in front of the absolute value. So it's y is greater than or equal to 2 times the absolute value of x minus 1/2. Now that's in general or standard form, where it's a times the absolute value of x minus h. First step is to pick out the vertex. We're going to graph the boundary y equals 2 times the absolute value of x minus 1/2. The vertex is located at hk. Now h is this 1/2. The x-coordinate of the vertex is 1/2. There is no k showing out here after the absolute value sign. It's just going to be 0. So the x-coordinate of the vertex is 1/2. The y-coordinate of the vertex is 0. And then the slope of the right branch, that's this 2 out in front of the absolute value. So the slope of the right branch is 2. Which direction are we going to shade? When it's in general form or standard form, look at the inequality sign. If that's greater than or equal to, greater than, you're going to shade above the boundary line. If it's less than or equal to, you shade below the boundary line. If you're not sure or confused, use a test point. And you can always use 0, 0, just so that 0, 0 is not on that boundary line. So the vertex is at 1/2, 0. Slope of the right branch is 2. From that vertex, go up 2 into the right 1. The left branch is, it's symmetrical, so the left branch, the slope would be -2. Go up 2 into the left 1. That's the boundary. That's a solid line because you have the greater than or equal to sign. I told you we would be shading everything above that boundary because we have a greater than or equal to sign when it's in general or standard form. If you're not sure, use the test point 0, 0. I can tell you right now, 0, 0 is not going to be a solution because we're going to be shading everything above that boundary line. So you get 0 is greater than or equal to the absolute value of -1. That means 0 is greater than or equal to 1. That's false. 0 is not greater than 1, nor is it equal to 1. That's a false statement. You're not shading the side 0, 0 is on. You're shading everything above that boundary line. You would have known that back here looking at this sign. Shading everything above that boundary line, that is the graph of y is greater than or equal to the absolute value of 2x minus 1. Going to graph y is less than or equal to the absolute value of 3x plus 1. Again, we have a 3 in front of that x. To get this in general or standard form, that has to be strictly x with nothing in front of it. So we're going to factor 3 out, move that 3 out in front of the absolute value. So y is less than or equal to 3 times the absolute value of x plus 1. So that's general form right there. And looking at the sign, you know this is going to be shaded below the boundary line because you have a less than or equal to sign. Also, you know the boundary line is going to be solid. So you know it's going to be a solid boundary and everything below it will be shaded. So just to graph that boundary, the vertex is going to have a location of 0, 1. Because in general form, y equals a times the absolute value of x minus h plus k. There's nothing after the x here. That means the x coordinate of the vertex will be 0. The y coordinate of the vertex will be 1. So the vertex is located at 0, 1. And then the slope of the right branch, that's the number in front of the absolute value, that's 3. So for your boundary, to get started, put a point at 0, 1. That is the vertex. And from that vertex, the slope of the right branch is 3. Go up 3 into the right one. And the slope of the left branch is negative 3. Go up 3 into the left one. So that is the boundary, and I told you we would be shading below that boundary line because when it's in general or standard form, you shade in the direction of the inequality sign. If you're confused on which way to shade, you can always use a test point. It just takes time. If you use the point 0, 0, that's the easiest one to work with as long as 0, 0 is not on that boundary line. So put 0 in for x and 0 in for y. I can tell you right now this is going to be a true statement because everything below that boundary gets shaded based on that sign. 0, 0 is going to make a true statement. You get 0 is less than or equal to the absolute value of 0 plus 1. It means 0 is less than or equal to 1. That's a true statement. 0 is less than 1. So since that's a true statement, again, you are shading everything below that line, including these points up here, not just below 0, 0. You're shading all of these points below the boundary line. So all these points get shaded. All of these points are solutions to that inequality, including the ones on that solid boundary line. Remember, a solid boundary line indicates that those are solutions. A dashed boundary line indicates that those are not solutions. So if it's a solid line, all of those points on that solid line, in this case, also the shaded region, those are all solutions to that inequality. Going to graph 1 minus y is less than or equal to the absolute value of 2x minus 3. I can tell you right now, you have to be careful of your signs, be careful of your shading here. This is not in general form or standard form. And also your y is negative. That's telling me the inequality sign is going to change as I'm working through this, which tells me to watch my shading, watch my negative signs. So to get this in general or standard form, first thing I want to do is subtract 1 from each side. You want to get y by itself, everything else to the other side. So if you subtract 1 from each side, you have negative y is less than or equal to the absolute value of 2x minus 3 minus 1. And negative y. To make that a positive y, divide each side by negative 1, and don't forget to change your inequality sign. Y is greater than or equal to the negative of the absolute value of 2x minus 3 plus 1. So we took the negative of this absolute value, and the negative of a negative 1 became a positive 1. And also, since we divided by a negative number, we changed the inequality sign from less than or equal to greater than or equal to. So right now, looking at that greater than or equal to sign, I can tell you when we get the boundary line down, everything above that boundary line is going to be shaded based on that inequality sign. We have a little ways to go yet to get to the boundary, because we have a 2 in front of the x. Remember, to get this in general or standard form, that has to strictly be x. If there's something in front of it, you need to factor that out. So we're going to factor 2 out, and when you factor 2 out, you're dividing each of these terms by 2. So 2x divided by 2 is x, and then negative 3 divided by 2 is negative 3 halves. And then you're simply going to move that 2 in front of the absolute value. So it's now y is greater than or equal to negative 2 times the absolute value of x minus 3 halves plus 1. That's in general or standard form. You can see the vertex, and you can see the slope of the right branch. So the vertex is going to be at 3 halves 1. And the slope of the right branch is going to be at negative 2. So the vertex is at 3 halves 1. Go to the right 3 halves, that's 1 and 1/2, and up 1, put a point. That's the vertex. The slope of the right branch is negative 2. So from that vertex, go down 2 into the right 1, put a point. And the slope of the left branch would be just negative 2. Or, I'm sorry, positive 2. It's the negative of negative 2, which would be positive 2. So the slope of the right branch would be 2. To get that from here, you would go down 2 and to the left 1. 2 negatives make a positive 2. So down 2 and to the left 1, that's the slope of the left branch. So slope of the right branch, again, is negative 2. Slope of the right branch would be positive 2. It's a solid line because we have a greater than or equal to sign that is a solid boundary. I keep calling it a line. It's not really a line. It's a V-shaped graph, but it's a solid boundary. So all we have left is the shading. Look back to when it's in general or standard form. Shade based on that sign. If it's greater than, you shade above. If it's less than, you shade below. If it's greater than or equal to, we're going to be shading everything above that boundary. If you're confused on the shading, you can always put a test point in. 0, 0. But I can tell you right now, since we're shading above, 0, 0 will be a solution. So if we put 0 in for x, 0 in for y, we're going to end up with 1 is less than or equal to the absolute value of negative 3. It's 1 is less than or equal to 3. That's a true statement. 1 is less than 3. So 0, 0 is a solution. That means 0, 0 and all the points on the same side of that boundary as 0, 0 get shaded. So we're going to shade everything above that boundary. All of those points in that shaded area, all of those points to infinity and beyond are solutions. Remember, this goes on forever. It doesn't just stop in this little box. It goes on forever. So all of those points are solutions to this inequality. That is the solution set. That's what the graph of that looks like. The graph of which absolute value inequality has its vertex at 1, 5. Well, all of these are in general or standard form. They're all solved for y. There's no number showing up in front of the x. So they're all ready to go to pick out the vertex. So all you have to do is find the one with the vertex of 1, 5. Remember, general or standard form is y equals a times the absolute value of x minus h plus k. hk would be the coordinates of the vertex. So you're looking for the one with the vertex of 1, 5. If the x-coordinate of the vertex is 1, that's going to be the absolute value of x minus 1. And if the y-coordinate of the vertex is 5, it's going to be plus 5 after the absolute value sign. So you're looking for one with absolute value of x minus 1 and then plus 5. And the only one that fits that bill is letter F. Y is greater than the absolute value of x minus 1 plus 5. That is the absolute value inequality that has a vertex of 1, 5. Letter F.